Hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. So we're starting our next chapter, last chapter, chapter number 14, Semiconductor Electronics. So modern electronics part of physics. So first we have to study in this chapter, we have the syllabus. In our syllabus, first topic is energy bands in conductor, semiconductor and insulator. Okay. So what are these conductor, semiconductor and insulator? These are solids. So we have to differentiate solids in the form of their energy band gaps because we have to realize the energy band in conductors, semiconductor and insulator. So first topic will be classification of solids on the basis of energy bands because we have three types of solid. First it is called insulator, then semiconductor, then conductor. Okay, make the first heading classification of solid on the basis of their energy bands. On the basis of their energy band. Student, as we know, there are in chemistry, a solid is made up of some element and it having some electrons. Yes, they having some cells in that electrons are filled over there. So, like if you're talking about sodium, the electronic number of sodium is equals to 11. So this is equals to 2, 8 and 1. Clear? So if I talking about the valence electron, 2, 8 and 1, this is first 2, 8 and then it is 1. Till the time this electron is present in the shell, this is called electrons of valence band. Clear? Valence band is a low energy band, or you can say till the time the electrons are connected or bound in the lattice of an atom, then they are said to be the electron of the valence band. But by giving a very few amount of energy, very less amount of energy, okay, as the attraction force from the nucleus is very less on this electron and sodium is highly electropositive, so it will leave this electron. Yes or no? After losing this electron, electron having higher energy, so it will switch its band from a lower energy band to a higher energy band. The upper energy band is called conduction band. Conduction band. Clear or not? Till the time electron is present in the lattice, or you can say in the valence band, it cannot conduct electricity. But once it gets out of the shell, it is free to move. Okay, and after applying some potential, like you have applied a plastic plate here, so it is free to travel towards this direction and current will flow. Means what electrons are responsible for the flow of current? Only the electrons in the conduction band. Clear or not clear? So essentially, for a solid for a solid materials, there are two types of band. One is called conduction band, and another is called, sorry, it is valence band, not conduction band. The low energy band is called valence band. Okay, and the higher energy band is called conduction band. Clear? And the gap of energy between these two band is called EG, forbidden energy gap, or energy gap. Simply, it is called energy gap. Clear? Yeah, so there is a difference between all the three type of material, conductor, insulator, and semiconductor. For this energy gap, let us see insulator. So first, this is insulator. You can check here. This is ground energy 0. Above then some energy, valence band having some energy. And there is a huge gap between the valence band and conduction band. So it is very difficult to transit a valence band electron to a conduction band because there is a very much gap between the valence band and conduction band. Fine. So in insulator, the valence band is completely filled. Yes, like insulator means carbon. The valence band is completely filled. First it is 2, after then it is 4. 1, 2, 3, 4. You know, it is practically impossible to remove the electron from the shell of carbon, valence shell of carbon. Okay, so these are the electron remaining in valence shell. Clear? So in a valence shell, there are so much number of electrons. So in insulator, the valence band is completely filled, whereas the conduction band is completely empty. Clear? Because there is no provided electron for moving. So there is conduction band is empty, but the valence band becomes filled. Got it? Yes. As there is no electron in the conduction band, so no electric conduction is possible, because if there is no electron, however you apply the potential, if there is no electron, then who will move? No one. So is there is no electron in the conduction band, so no electrical conduction is possible. The energy gap between conduction band and valence band is so large. Here energy gap is greater than, even greater than 3 electron volt. That is very quite high. Okay. So energy gap here is 3 electron volt, that no electron in the valence band can provide it so much energy for any external source that can it jump to this energy gap. Okay, so practically this amount of energy cannot be given to any electron. So it cannot transit from the valence band to the lower band or conduction band. So not at all current will flow from the insulator. Got it? Next material is semiconductor. Semiconductor, the energy band structure of a semiconductor is shown figure B. It is similar to that one of an insulator, but remember here as the energy gap is some slightly lesser than the previous one with a comparatively small energy gap. Yes. Previously you seen the energy gap is very greater, that is like 3 electron volt. Now it is the energy gap is less than 3 electron volt. Okay. Yes. Example 1.1 electron volt. Okay. Means this level energy band gap is some less. So what happening is less than 3 electron volt. At absolute temperature, the conduction band of semiconductor is totally empty and the valence band is completely filled. Yes, there is another theory. Let us see some important things. See, semiconductor are the material like silicon. For a zero temperature, 0 Kelvin temperature, it's behave like a non-metal. And for a room temperature 300 Kelvin, it's behave like a metal. That's why it is partially non-metal, partially conductor and partially non-conductor. That's why it is called semiconductor. So what is happening there? Like see the situation at 0 Kelvin. At 0 Kelvin, like here gap is equals to 3 electron volt or less, 2.8 electron volt. Okay, say the gap is equals to 2.8. At 0 Kelvin, at 0 Kelvin, absolute energy of any ion equal to 0. So at 0 Kelvin, it cannot jump. Okay, it cannot jump. So the electron cannot transit into the conduction band. Yes. At absolute temperature, means 0 Kelvin. The conduction band of semiconductor is totally empty and the valence band is completely filled. So at 0 Kelvin, there is no energy, means the valence band will be completely filled. And there is no electron in the conduction band, means no conduction at all will be there. Yes. Therefore, they are insulator at low temperature. Important line, these materials are insulators at a low temperature. However, at room temperature, some electron in the valence band acquire thermal energy greater than the energy band gap and jump over to the conduction band, where they are free to move under the influence of an even a small electric field acquire a small conductivity. Hence, the resistance of the semiconductor is not as high that of insulator. It is lesser than insulator. Okay. So what will happen when you increase the temperature of the crystal? Some of the electron jump into the conduction band, and after applying positive and negative potential, the electron will flow and will constitute a current. Got it? Yes. So these are semiconductor. Now conductors. Conductors, check here the diagram of the conductor. You can see the conductors in the conductor energy gap is almost zero. Even these two bands are overlapped each other. Means conduction band has share some area, common area with the valence band. These both the two bands merge together. Okay. So energy gap is almost zero, and there is no band gap exists. So electron can transit from valence band to the conduction band very easily. So let us read the theory. Conduction. Conductors are called metal. In case of metals, either the conduction band is partially filled and valence band is partially empty. Why? Because some of the electron transited from the valence band to the conduction band. So still some electron there in the valence band and some of the electron there in the conduction band. So it is partially filled or partially empty, both the bands, and valence electron or conduction band and valence band overlap each other. In case of overlapping, the electron from the valence band can easily move into the conduction band. Thus, large number of electrons are available for the conduction. In case of valence band is empty, electrons from the lower level can move to the higher level, making conduction possible. Yes, yes. See here, a new thing is there. In case conduction band becomes empty, now conduction band becomes empty, so no electron is there. But sorry. After valence band becomes empty, not conduction band. After valence band become empty, the conduction band will be full, clear? But the conduction band electron having different energy levels. Like these are the energy levels, okay? So these electrons also having a capability of transiting from lower level to higher level. So because of that, the current will flow through the crystal. So in case of valence band is empty, electrons from its lower level can move to the higher level, making conduction possible. This is reason why resistance of the metal is low or conductivity is high. Yes, this is the reason that for a metal resistance will be low and conductivity will be high. Got it? So difference between all the three categories of material, difference between the conductor, insulator, and semiconductor. First, conductors. In conductors, the conduction band and valence band are partially overlapped to each other and there is no energy gap between them. So make this diagram of conductors. You see this is valence band and this is conduction band. Now valence and conduction band are overlapped. Previously the conduction band is up to here, but some of the area is overlapped here. This is called conductors. There is no energy gap. So if anyone asks what is energy gap here, equal to 0. Then for insulator, there is energy gap is greater than 3 electron volt. That is quite high as perspective of an electron. This energy is very high. So there is empty conduction band and filled valence band. Yes, valence band is filled and empty conduction band is empty. For semiconductor, yes, here the diagram is at 0 Kelvin. The filled valence band will be there, but the conduction band will be empty. After giving some amount of heating, the electron from the valence band will jump into the conduction band. Fine. And the energy gap is less than here, less than 3 electron volt. Semiconductors. In semiconductors, the valence band is totally filled and the conduction band is empty, but the energy gap between conduction band and valence band is quite small. It is less than 3 electron volt. Underline. For a germanium, it is 0.72 electron volt and silicon, it is 1.1 electron. These are typical semiconductors. For a silicon semiconductor, energy gap is equal to 1.1 electron volt and for germanium it is energy gap equal to 0.72 electron volt. Okay, at 0 Kelvin temperature semiconductor behave as a insulator. Yes, I told you at 0 Kelvin temperature the electron motion will be stopped there, so no electron can transit to the conduction band, so behave like a insulator. Yes. Next, insulator. In insulator, the energy gap is quite large. That is, Eg is greater than 3 electron volt. Due to the large energy gap, no electron is able to go from the valence band to the conduction band. Hence, electrical conduction in these materials is not impossible. So they behave like a insulators. Clear? Now, what are bands? There are three type of band in every material. These are called energy band in solid. Valence band. This energy band contains valence electron. This band may be partially or completely filled with electrons but never be empty. Yes, it may be partially filled, it may be completely filled, but it is never empty. The electron in this band are not capable of gaining energy from external electric field to take part in conduction. Yes, because these are the valence band electrons are the electrons from the lattice. Yes. So like when you stuck in the lattice, then no positive and no negative can move you, because once you getting out of this lattice, then only you are permitted to move, because you supposed to be as a free electron, but now you are a valence electron. So you cannot be move, you cannot move even after by applying external electric field. Clear? Next is conduction band. Yes. This band contains conduction electrons. Yes, free electrons, conduction electron. This band is either empty or partially filled with the electrons. It may be empty. For a perfect insulator, the conduction band is totally empty. Okay, and for a conductor or metal, it is perfectly filled. Okay, the electron present in this band can take part in the conduction of current just by applying positive and negative terminal or electric field. Clear? Forbidden band. The band is completely empty. This band is completely empty. So forbidden band means the band between the conduction band and valence band is called forbidden band. As temperature increases, the forbidden energy gap decreases. Obviously, when you increase the temperature, then the electron will jump here and the energy will be decreases. Clear? Note, the minimum energy required to shift an electron from valence band to conduction band is called band gap. So this energy that is required to switch the electron from the valence band to the conduction band is called EG, or energy gap. Student, our next topic is type of semiconductors. Okay, there are two types of semiconductor. First, like you have a pure semiconductor. So first category is pure semiconductor. Clear? Second is impure semiconductor. Yes, pure semiconductor. Pure semiconductor are also called intrinsic semiconductor. Fine. An impure semiconductor is called extrinsic semiconductor. Clear, beta? So these are called pure semiconductor and impure semiconductors. Intrinsic semiconductor, there is no impurity, and extrinsic semiconductor, there is a impurity. So what type of impurity you are mixing here? When you there are two classification in impure semiconductor. One is called P type semiconductor and another is N type semiconductor. P type means when you mix a pure silicon with trivalent impurities. Trivalent impurity means 13th group. 13th group, okay? Boron, aluminium, gallium, indium. So if you mixing these impurities with a pure semiconductor with silicon or germanium, you will have a P type of semiconductor on mixing trivalent impurity or 13th group elements. Clear? On mixing 15th group element with a pure silicon. 15th group. Which 15th group? Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen is a gas, so you cannot mix it, but you can mix phosphorus, arsenic, and antimony. So then you have a resulting semiconductor is called N-type semiconductor. Clear? So there are two types of semiconductor. First, it is intrinsic semiconductor. Then after it is extrinsic semiconductor. Intrinsic, there are only one type, and in extrinsic, there is P type and N type. The process by which you mix these impurity is called This process is called doping. Fine.